We're looking at the January 2021 CSEC Mathematics past paper. We're now at question 6. What it says is, in this question, take pi to be 22/7. Alright? The diagram below shows a rectangular tank with a base 50 centimeters by 40 centimeters. So we have the base there. Alright? 50 centimeters, you have the 40 centimeters there. That is used to store water. The tank is filled with water to a depth of 15 centimeters. So we have it here. Calculate the volume of the tank, of water in the tank. Now I've copied the question over here already. So right now, pause the video and work this part out. Okay, you're done. What did you get? Let's look at working this part of the question out. Here, you have the height 15 by the width 40 by the length 50. I left off the centimeters for now. So it's 15 by 40 by 50. How much is that? That would be 15 4 60. 600 by 50 would be what? 6530, and then you have 3 more zeros. So that's 30,000 centimeter cube. See that? Right? So that's 30,000 centimeter cube. 30 centimeters cube. Now, cm cube, all right? 30,000 cm cube would be the height or the volume. And remember, the centimeter cube would come from centimeter by centimeter by centimeters, right? If I had put the centimeters part in it, I could have said this is 15 cm by 40 cm by 50 cm. So it would be cm by cm, which is centimeter square, by cm, which is centimeter cube. Right? Hope you're seeing that. So there you have it. That's the volume of water in the tank. Let's see what else they're saying here. Alright, part B. Let's just copy part B also and put it over here. Let me just paste it. Now, part B of the question here. Let me drag it down and then read it from over here. The cylindrical container shown in the diagram below is used to fetch more water to fill the rectangular tank. You notice they put the more in bold. The container, which is completely filled with water, this container is completely filled with water, has a radius of 20 centimeters and a height of 21 centimeters. All the water in this container is added to the water in the rectangular tank. Calculate the total volume of water that is now in the rectangular tank. Alright, so here, what strategy are you going to use? Remember now, you had the cylindrical tank before with some water in it. Now, you had the rectangular tank before with some water in it. You see that? Now you have the cylindrical container you fill the cylindrical container and are going to add water to the rectangular tank. Now, you're supposed to find out, after you throw all this water in the rectangular tank, how much water, the total volume of water that is now in the rectangular tank. Of course, the strategy is to find out how much water is in the cylindrical container and add it to the volume in the rectangular tank. So go ahead and calculate the amount of water in this cylindrical tank, in this cylindrical container. Okay, good. You're done. You're finished. What did you get? Let us see. We're going to, let me just expand this part of the question a little more. Here now, the volume in the cylindrical tank, let us call it VC. You know, the volume of a cylinder is pi r squared times the height. In this case, they had said, remember, they had said to use pi as 22 divided by 7. So let's do that. So in this case, it is 22 divided by 7 times the radius, 20 squared. 20 squared is the same as 20 by 20 by the height, 21. And it's going to be in centimeter cube. As remember, the radius is in centimeter. When you square the radius, you have centimeter squared times the height in centimeter. So you end up with centimeter cube, alright? So you will get the volume in centimeter cube when you're done. Now here, VC, volume of the cylindrical container, is, let's just see if we can cancel out anything. We know that there is 1 7 in 7, right? There is 1 7 in 7, and there are 3 7s in 21. What else can we do here? Alright, let's work with this for now. So far, we see that we have 22 times 20 by 20 by 3. Alright, so this is what we have. Let's just use our calculator and quickly get this. Wait for it. Alright, calculator is loaded up. We have 22 by 22 by 20 by 3 equal 29,040. So we have 29,040 cm cube. Okay. Now the total volume of water after you add all this water to the container, remember, to the rectangular container, it was 30,000. Alright, 30,000 plus 29 something here, so call it VT. V total volume is 30,000 plus 29,040 would be what? When you add them up, you will get 0409 and 00. I mean 9, 135, 59,040 cm cube. Right? Was that what you got? Okay, let's see what else is there. Show that the new depth of water in the rectangular tank is 28.2 centimeter. Alright, 28.2 centimeter. So we're going to show that the new depth is equal to 28.2 cm. What were the dimensions of the cylinder again, of the rectangular container again? 50 by 40, 50 wide, 40 wide, 50 long. So if you consider it as this, you have 40 cm wide, 50 cm long, and you want the depth of water. If you have 59,040 centimeter cube, it means 40 centimeter. Let me put the centimeter here. 40 centimeter by 50 centimeter by whatever it is, d centimeter is equal to, well, they say it's 28.2, you should show it, is equal to 59,040 centimeter cube. So d now would be 59,040 divided by 40 by 50 equal 59,040 divided by, what is 40 by 50? 4, 5, 20, 0, 0, 2,000. What is 59,040 divided by 2,000? Let's get our calculator and work that out. What we have is 59,040 divided by 2,000 equal. So we have 29. Well, they say 28.2. Let's see what is happening here. If there is some error, 4, 5, 20, with 15, we had done 15 by 40 by 50. That's 15, 460, 600, 5, 6, 30, 30,000, good. Pi r squared h, pi times 20 squared times the height is 7 into 7, 1, 7 to 21, 3, 22. Oh, there was a mistake here. This should be 20, not 22. Hope you had spotted that. This should have been 22 by 20 by 20. Alright? So, here, going to have to calculate that part again, because there was an error there. So it was supposed to be 22 by 20 by 20 by 3 equal 26,400. So it's really 26,400 cm cube. And then here the total would have been, when you added the 26,400, would be 0, 0, 4, 6, 3 and 2, 5, 56,400. So this would have been 56,400 over that. So you have 56,400, 56,400, 56,400. Let's do that again. So it's 56,400 divided by 56,400 divided by 2,000 equal, right, 28.2. So we have it now. So it's 28.2 centimeter would be the new depth, and they ask you to show it, right? So once you do that, you can write SHOWN, shown. That was shown. All right, so there you have that. So here now, what you have as the answers, this part B, all the water is added, so you have this part, container 26,400. So the answer to this part of the question, part B, was 56,400. Let me just make a note of it right here. 56,400 cm cube. And then of course the next part is for you to show that the depth is 28.2. all right, so let's see what else is there. Oh, part D here. Let's look at part D and see what they say. The vertical height of the rectangular tank is 48 cm. Okay, determine how many more cylindrical containers of water must be poured into the rectangular tank for it to be completely filled. Alright, 48 cm. So the vertical height is 48 cm. Okay, so it's 50 by 40 by 48. Let's see what is going on here. If we consider now the tank, this was what, 40 wide, 40 by 50 by 48. Let me just make an adjustment to these lines here. Alright, so this is 40 by 50 by 48. Let's call it that. Alright. Not really trying to draw it to scale, but to make it kind of look more, what would you say now? More like the dimensions that I'm talking about here, more proportional. 40 cm, 50 cm, well, kind of look off. By 48 cm, was that what they said? Let me look again. Yeah, vertical height 48 cm. Determine how many more cylindrical containers. How many more? All right. So remember, this is what? This is part D. All right. This is part D of the question. Remember now, you already have some water. You already have 56,400 cm cube of water in the tank. Now, the cylindrical container was 26,400. So you're going to find out what volume of water would be there when the tank is full, and you're going to take away how much water is already there, and the difference now, how many of that cylindrical container would be needed to fill it. So pause the video and go right ahead with that. Okay, good. You have done it. What did you get for your answer? Let's see. Now, the volume here will be 40 cm by 50 cm by 48 cm. Remember, you could have, or you can rearrange this to say 40 by 50 by 48 by cm by cm by cm. That shows a number and then cm cube, right? 50 by 40 by 48. How much is that? Let's just quickly get that with our calculator. 50 by 40. 50 times 40 times 48 equal 96,000 cm cube. All right, so that's the volume. Now the thing is, how much water is already there, right? Volume that is there. What's the volume that is there already? 56,400. All right. We had added it. Remember, we had this 30,000 cm cube, this cylindrical container. We found it to be 26,400. We fill it, added it to the 30,000 and get 56,400. So there are 56,400 centimeters cubed there already. So 56,400 cm cube is there already. Now, how much more is needed? I'm just calling it V needed. Let me rewrite that. V needed. The volume needed is 96,000 minus 56,400 equal. Let's just use a calculator to work that out. 96,000 minus 56,400 equal 39,600. So 39,600 cm cube you need to fill the tank. Now, the volume of each of the cylindrical container, I just call it V each cyl. What was it again? It was 26,400. So it's 26,400 cm cube. All right. So you're going to say, how many cylindrical container are in the volume of water needed? So therefore, how many 26,400 are in 39,600? So you're going to divide. So what they say, remember what they ask you for. Determine how many more cylindrical containers of water must be poured into the rectangular tank for it to be completely filled. You need 39,600 centimeter cube more to be completely filled. And each cylindrical container is 26,400. So you say 39,600 divided by 26,400. This is saying how many 26,400s can go into 39,600. In other words, how many full cylindrical container can go into the water needed to fill the rectangular tank. What do you get? Let's just use our calculator again. So that's divided by 26,400 equal 1.5 or 1.5 more cylindrical container. That's what you need. 1.5 more. Alright? Let's see what else is going on. Oh, good. Nice. That's the end of question 6. We'll do question 7 next time.